If chicken nuggets only came in boxes of 6, 9, and 20, what is the largest order not possible? Let's find out. So let's assume that the answer is less than 100. Let's first cross off the multiples of 6, 9, and 20 because we can order those amounts of nuggets. Now, what are some other combinations we can cross off? Well, one of them is one box of 6 and however many boxes of 9. So let's cross off numbers of this form. And let's do the same thing with one box of 6 and however many boxes of 20. And let's continue by looking at one box of 9 and however many boxes of 6, and one box of 9 and however many boxes of 20. Now let's look at two more cases. One box of 20 and some number of boxes of 6, and one box of 20 and some number of boxes of 9. Let's cross those out. Now let's take a pause over here. Take note that we have 6 numbers in a row that are crossed off. And this is significant because we can always order 6 more chicken nuggets. So if we keep adding 6 to each of these numbers over and over and over, we would eliminate all of the numbers greater than these numbers. Now it's very tempting to say that 43 is the answer because it's the largest number left. But remember, we didn't consider every single combination. So let's verify that 43 cannot be written in this form. Now, a number like 35 can be written in this form, but that doesn't matter because 43 can't. So 43 is the largest order not possible. Now, what we just did is called the Chicken McNugget theorem, or the Frobenius coin problem. Let's take a look at the case with two numbers a and b. A and b have to be relatively prime, meaning they have no factor in common besides 1. So the largest order not possible is given through a times b minus a minus b, or the product of the numbers minus the sum of the numbers. So for example, if Chicken McNuggets only came in boxes of 4 and 11, the largest order not possible is 29. Now with 3 numbers, it's a little more complex, but still doable. With 3 numbers a, b, and c, we would have to choose our c so it divides the least common multiple of the other 2 numbers. Then we would use this expression. So with our original problem of 6, 9, and 20, 6 would have to be our c, and when we compute, we see that we would get 43 as our answer.